Imagine a scenario where we have a queue of people in a banking hall or a queue of people in a restaurant. Now let's say this establishment they operate a first come first serve policy. Now as you can imagine, in such a situation, the first person on the queue gets served, followed by the next person and the next person, on and on like that. You get the idea. Now, in Python, this behavior is known as first in, first out behavior. And then we get this behavior when we perform operations on our list using dot append and dot pop zero methods. So this, when we do something like this, we get what is known as first in, first out behavior. Let me show you. Let me just, so as you can see here in this diagram, we have deque, we have queue, front, back, front, back. So this image is depicting, what is it called? Is depicting the head of a list, that is the zero index end. Okay, so deque means double-ended queue. Okay, let's go to our terminal and demonstrate this concept with some program. Okay, so I'm going to open IPython. I'm going to use this to demonstrate the first in, first out behavior, and then we get to deque and queue. Okay, now in the previous tutorial we have looked into types and methods used on collection type, specifically the list type. Okay, so you'll be familiar with the code I'm about to write. So if I do letter, no, so symbols, for instance, and then I do A, B, C, D, E. Okay, let me stop at that. And then let's say I do codes, and then set this to an empty array, empty list, sorry. Okay. I'm going to try to populate this codes list, and then I'm going to use the for loop here just to demonstrate the append. I could have using list comprehension, but I want to use, I want to speak on the dot append method, how it applies to the head of a list. Okay, so we can do for symbol in symbols, and then we can do codes dot append. Okay, and in here I'm going to do the hard method, and here I'm going to pass symbol. So here, what the hard method is doing here is it's returning an integer representing the Unicode code points of a specified character. So here, when we do the hard method and we pass our iterator variable here, what we are saying is return an integer representation of this character, this symbol's character. Okay, so we're going to try to return, populate this with the Unicode code point of this character. Okay, so if I go enter, and then I do, what is it? What have I done wrong? Okay, I think, yeah, I've made a mistake here. Let me go back. Okay. So here when if I do codes, sure enough, we have what is it called? Unicode code point of this character. So what this is saying is that letter A has Unicode code point of 65, letter B 66, like that. Now, when you look at this loop, we're doing codes.append, okay? Now we are appending the code point of each of these symbol. So it's going one after the other, okay? One after the other. 65, 66, 67, 60, 69, like that. Now, if we wish to pop from index 0, what we can do codes. Remember what we said about pop. So if we specify um, the index, then it removes the item from that specified index, okay? And then it returns it. So here if I do enter, see, it pops, it removes 65 from our codes list. So if I do codes now, see, we have 66, 67, 68, 69. And this is fine, except there is a problem with this. And the problem is this, and the problem with this is this. When we insert and remove from the head of our list, that is the zero index end, this operation can be costly in the sense that we are, what is it called now? In the sense that we are reordering our entire list in memory. That is, our entire list in memory is being shifted when we do this dot append and dot pop the zero, that is inserting and removing from the head of our list, that is from the zero index end. What is happening is our entire list is being shifted in memory. The operation can be costly in that regard. So what if there is a way where we can insert and remove from the head of our list without necessarily shifting our entire list in memory? So we wish to quickly do something with our list without necessarily shifting our entire list in memory. Or say we wish to retain what is it called? So we wish to retain a list depicting our last seen item. Okay? Python offers us a way to do this. And the way we do this in Python is to use collections.deque objects. Collections.deque objects is how we got here, Deque and Queues. Okay? So with our collections.deque objects, there are some inbuilt methods that we can call on our collections.deque method that will allow us to insert and remove from the head of our list, that is from the zero index end, without necessarily shifting our entire list in memory, if that makes sense. Okay, so I'm going to demonstrate this. Collections is an inbuilt module in Python. So we have to import it from our Python. Okay, and then we're going to import the deque method from our collections objects, which is an inbuilt module in Python. So the way we do this is to do from collections import deque. Okay, like that. Now we can do deque equals then we call this Deque method. Okay, then we now specify or we define what our list, what the body of our list is going to be. Say we decide to go for range 10. You already know what this is going to do. Okay, it's going to populate our Deque list, our DQ list, with integer values from 0 to 9. Okay, so if I press enter, then I do DQ. No, DQ. Sure enough, we have a list of items, numbers from 0 to 9. Then it has this Deque flag. Okay. Now, our collections.deque objects has some inbuilt methods that we can call. Okay. And so when we call these methods allow us to insert and remove from the head of our list, is from the 0 index end, without necessarily shifting our entire list in memory. Okay, so one of those methods is rotate. Okay, so rotate, we take an argument, and the argument we specify to our Deque collection from which position, that is from what step to rotate our Deque collection. Okay, so let me show you. Then we can do DQ dot rotate. No, dot rotate, and then this takes an argument. Whatever this argument is an integer. Okay, so whatever integer we pass here, we specify to our Deque collection this number of steps to take in rotating our Deque collection. It's more nuanced than that. So let me just show you. So if I do DQ.rotate, remember DQ is the variable pointing to our Deque collection here. So if I do DQ.rotate, for instance, if I do 4, let's see what we get. Okay, so if I do DQ now, see what is happening here. See, when we call the dot rotate method and then we pass this argument, this 4, what this is saying is move the last 4 items inside our Deque collection. That is, the last 4 items on the right, then move those items to the left. Okay? Move those items to the left. So here we have the last 4 items, 6, 7, 8, 9. So these items are on the right. It's the right end of our, what is it called? Of our Deque. So this rotate method with this argument is say, okay, move the last 4 items on the right to the left. And that's what is happening here. 6, 7, 8, 9. Okay? Now, if you pay attention to what is happening here, we still have the same items inside our Deque here. The only thing that is happening is we are rotating, we're moving some of the items here from the right to the left. We still retain the same number of items. Okay? So here, we're not necessarily shifting our entire list in memory. If that makes sense. We can also do DQ.rotate. Let's say -3 now. What does this do? So if I do DQ, okay. So for the -3, remember where we were here. This is our original Deque collection. Now when we do DQ.rotate, we're saying, okay, move the first 3. This is negative now. When we did positive, we went from right to left. Now negative, we're going from left to right. So this is saying move the first three items from the left to the right. Now this is where we were, sorry. When we rotated, this list has been changed in a way. So now this was our current list prior to us performing this rotate then negative minus 3 operation. So whatever this is going to act on this, not this, just as this acted on this. Okay, so this dq dot rotate minus 3, this argument is going to do whatever it does on this. Okay, so it's saying move the first three items on the left to the right. Okay, so it's like the reverse of what we did when we did for positive argument. So the first three items on the left, 6, 7, 8, move this to the right. So it moves 6, 7, 8 to the right. Okay, so 9, 0, 1, 2, 3, 4, 5 gets moved to the left like that. Now you realize that the head of our list, that is the zero index end on the left and right side, like we said here, front, back, deck, okay, queue, front, rear, okay. So you realize that we're just moving things around here. All the items in our deck collections, we still retain them. None of the items has been lost. Okay, so not only that, we can also say we wish to append on the left. We can do dq dot append left. I don't know. So we wish to append -1 on the left, and then if we do dq, okay, now -1 has been appended on the left. Okay, remember this is what we started with now, because we've sort of like what is it called now? Transform our collection to this point. So when we do append left -1, so -1 is being appended on the left, then the rest of the items in our deck collection is being represented here inside our deck list. Remember we said deck is double-ended queue. Okay, so that's that. We can also use we can do extend. So we can do dq dot extend, for instance, and then we can pass a new list here. So we do 11, 12, 13. Okay, and then if we do dq, okay, so our deck list has been extended by 11, 12, 13. Okay, we can also do, I don't know, maybe we do extend left. Okay, so if you do extend left, let's see, you can do dq dot extend left, and then here, so let's say we do -2, -3, -4. Okay, and then extend left. Okay, so if we do dq, sure enough, our deck collection is extended on the left. So the takeaway here is, for our collections.deque, our entire list, it's not being shifted in memory. In fact, our collections.deque method allows us to retain the lasting items in our list. So what collections.deque method, what it offers us is, let's just say, maybe it offers us a more efficient way to sort of like insert and remove from the head of our list, that is from the zero index end. As you can see, we're inserting and removing from the zero index end. Okay, so everything we're doing is from the left to the right, or right to the left, so to speak. So guys, this is Deques and Queues in Python list. I hope you've learned something. I hope to see you around next time. Thanks for watching.